I have no idea if this is a good idea, but whatever. Let's just do something. 20% battery. That's ridiculous. I guess we'll start with question number 5. E is a finite dimensional Euclidean vector space over the real numbers. X is a non-zero vector. Curly A is the set of all AX where A equal A star, positive definite. And the norm of A is bounded above by 1. Prove that curly A is equal to the ball, given as follows. Norm V minus X over 2 is bounded above by norm X over 2. Now, some people are here. Hello, everybody. Big fan. I don't know why I'm doing this, to be honest. But I figured I'm going to be sitting here suffering, studying for this test. I may as well try something I've never done before. Put this at the distance. Okay, so the left and side right inclusion should be, why is it so fuzzy? Should be fairly obvious. You can assume that the norm of X is equal to 1. Otherwise, we can just rescale and then, okay, I think I can do this during the exam, recreate this entire argument. I mean, it's just expanding the scalar product. Hello, more people that have come in. If you guys want to ask me questions, go right ahead. I'll answer them if I feel it's appropriate, but I am really just doing this to practice for my exam tomorrow. I don't know how long I'm going to be streaming this. My phone is going to die, probably. It's at 19%. But if you want to talk to me and ask me something, you're more than welcome to. I just randomly decided to start recording. He might ask me to explain this step that shows up here. Why is this negative? But I think it's obvious because of this requirement that's in the top. Have you ever done the Putnam exam? I have not. I'm not good at math. I'm gonna be honest with you. I'm really not that good at math. Everything that I've done, all my knowledge is borrowed. But I know how to get this step. Well, I'm not explaining this very well. I know how to get this step. This, I think, non-negative is pretty good. And then you just take the square root at the end. The other inclusion is much more difficult. So if you choose V in the ball and you get this inequality, that's again, given to us for free, more or less. We can assume the dimension of V is bigger than or equal to 2 because if the dimension is equal to 1, we know that any linear map should be of this form, which I believe is not that. Yeah, that's true. But he may ask me to explain that, which kind of sucks because I should be able to do it on the spot, but I don't know. What math YouTubers do I watch? I really like Numberphile, although he's kind of like math for people that don't like math but are kind of getting into it. Some of the stuff he does on the channel may be, I mean, I don't want to I do really like Numberphile, but he's not he doesn't get deep into math like, say, what's his name? Grant Sanderson. 3 Blue, 1 Brown. He's really good. I like 3 Blue, 1 Brown. I really like Michael Penn. He's really good. I like the Math Sorcerer. Do you ever feel like you're self-sabotaged during a pursuit of your goals? If so, any tips for dealing with this? Do you recommend going to probability and pure math or stats department if I like probability analysis? I mean, I think you should do what you want to do, as long as, you have an exit strategy. You don't want to be in a position where you get this degree, but it's worthless and you can't get hired. You do have to think about the future. Do I ever feel like I self-sabotage? Yeah, I self-sabotage myself all the time. I don't think this YouTube channel has really distracted me. I think it's actually helped me in the long run. I mean, doing the measure theory review, I wish I'd done it sooner. I'm in like I'm in the middle of doing the measure theory review. I need to do the back half, but everything's been put on hold for this test. So the trick in the second inclusion is you want to define this fancy pants linear operator H. And you need to define it in this way, which isn't too hard to remember. But another thing I'm worried that my instructor will ask me to prove is to show that it's a self-adjoint linear operator. The fact that it's a linear operator, I think, is pretty straightforward, but the fact that it's self-adjoint is probably a step I need to include. But after that, this inequality, I think, makes a lot of sense. Setting A to that makes a lot of sense. The fact that this follows based on what H isn't too hard to see. So the only thing here that I'm scared of in question number 5 is showing that it's self-adjoint, which, you know, you can just apply the definition and won't be that, it's not that bad, but I need to force myself to sit down and actually compute the stupid thing. Sending power for my exam, thank you. I have a lot of respect for you and everyone else that knows how to do this crazy math. Struggled through calc and failed by 5 points. Oh, I'm sorry to hear that. You have to retake it next semester. As long as you keep at it, you know, there's nothing wrong with that. Do you find math competitive or no? I think it's more cooperative. I find it that way. Everyone in the math department tries to help each other succeed. Some people get competitive about it, but I don't think that's healthy. So I wouldn't describe it as competitive. Should you use Thomas Stewart or more rigorous textbooks like Spivak and Apostle? I don't think it really matters. Just anything that's a reputable math book would be good. I use Stewart. Stewart's really good. I do projects and study all alone, but in class I have difficulties working with others because they try to derail you. I get derailed all the time whenever I'm trying to explain something to my advisor, which is annoying. Cauchy sequences in the chat. What do? You just gotta fight it. You just gotta fight for your voice to be heard, and eventually, when you build enough confidence, people will start listening to you. They won't derail you as badly. Problem number 6. I definitely need to prove problem number 6 for the exam. I wish I could do this sideways. I don't like portrait view. It says it's locked as portrait, but I guess we'll deal with it. I really do need to solve problem number 6 because that's where the bulk of my points are coming from. If I don't solve 6 on the test, then I'm screwed because he's not going to give any partial credit. Do you think if someone's good at math, can they be good at physics? They can be good at physics, but I would not call myself good at physics. I didn't really like it when I was studying it. What class made you fall in love with math? Probably Algebra 1 when I took it in 8th grade. That's when I really started to. I mean, I've always appreciated math, but that was like when it really started going. I really liked Algebra 1. A and B are positive definite self-adjoint operators, R3 to R3 over the real numbers. Determinant of A is 1, determinant of B is 8. Prove that the set of determinants of A plus B is equal to the interval 27 to infinity. The back half of this proof, meaning the superset direction, is I've done this so many times I don't even need to look at it anymore. I can do this straight from memory, so I'm not worried about it. It's the other inclusion where you have to use the Minkowski inequality that has got me upset because I was told that what I did was sufficient yesterday. And then today, a friend of mine told me that it's not sufficient. So that's kind of, there's probably a miscommunication here. But I'm just trying to make sure that all my T's are crossed and my I's are dotted. PhD in accounting is PhD with the best job outlook for becoming a professor. I took an accounting class once. What was the hardest undergrad math class for you? As an undergrad, remember I got my degree in environmental science. So I didn't go that deep as an undergrad. I would say math proofs, because that was when like I hit that big wall, you know what I mean? You hit that wall of proofs and you can't get past it. It was kind of the reason why, it wasn't the reason why I switched, but that was a huge hurdle that I had to get past. Favorite math book? Shoot, I don't think I have one. I mean, I really like this Kolmogorov book, or at least I used to. I still like it, but it could be, there's a lot of good math books out there. I can't really pick a favorite. Just, I can read a book and say, okay, this makes a lot of sense. I like this. Just curious about why the Quran in the pile. I noticed you were talking about Eid in one of your recent videos too. I wanted to add, a friend of mine in the math department, she's a Muslim woman, she gave me the Quran, and I've been thinking about reading it. And I wanted to include it in the pile as like, I felt like including it in the pile, but I didn't realize, someone had pointed out I shouldn't have other books stacked on top of it, and I didn't want to offend anyone in the people watching the video, so I hid the video, because I didn't want it to be offensive, you know what I mean? Because whatever, I was trying to do a good deed, and I feel like it didn't, no good deed is, what am I trying to say? No good deed is not punished, whatever. Is this the first live stream? Yes, it is. Do you listen to music during your studies? Yeah, I do. What kind of music do I like? I like weird stuff. Or not weird stuff, but stuff that you wouldn't expect, because I'm not that old, so I don't listen to, yeah, it goes unpunished, thank you. I don't really need to, I lost my train of thought. Eric Clapton. I've been listening to a lot of Eric Clapton recently because I like to play guitar. Am I familiar with the math works of Hugh Janus? That and Big Chungus. They're both great mathematicians. Okay, so this lemma is really the only thing I need to prove. Determinant of sum raised to 1/3. Okay, that's just a statement. So I need to choose a non-singular t where t inverse a, t inverse star is equal to the identity. And I need to choose a unitary matrix u star equals t inverse b, t inverse star u is equal to my positive diagonal matrix. Do you listen to Dream Theater? I don't know what that is. Face reveal? No, I'm not going to do that. Hey man, do you have any recommendations on number theory? I don't like number theory. I like the results, but doing it is painful. I try to do one complicated math subject at a time, which measure theory was the one that I chose. Have you thought about what you're going to do after your PhD? I guess postdoc, but maybe not. Hard to say. So after we've chosen t and u, I need to remember how to choose t and u. But after I choose them, I need to set s to be tu and then just substitute them here, which gives me this expression, which gives me I and lambda in the very end, so that when I solve for a and b, I get the following expressions. So then, when I pass it into the inequality, I get this guy. This is just algebra. This is not hard for me to remember to do. I can still do my algebra. But after I do that, the inequality becomes this. And proving that is something I've done like a million times. Like I can do this easy. So the only thing that has what got me worried for number 6 is making sure that I know how to define my s and my t's and my u's, which is what I need to go over. So my strategy is to get full credit for 6, hopefully full credit for 5 for 11 out of 12 points. And I don't know about this theorem tomorrow because I do not have all my theorems memorized. So I am screwed. What are your thoughts on class field theory? Andre Weil said it was the most beautiful subject. I'm very specialized. I don't know much outside of the classes I take, unfortunately. There is a lot of math I want to know, like topology. I'm taking topology next year. But I'm also kind of interested in just focusing on my one research problem. in convex geometry, and I'm not getting to do that because I have to take linear algebra 3 times apparently. Are there any specific books I recommend for discrete math and differential equations? Ugh, not really. I mean, I have an ODE book hiding down under there, if you're interested. Yeah, and I moved my Quran to the top of the pile, just to be nice. Who's your favorite math professor at my university? Probably my probability theory instructor. Okay, so let's look at the theorems. I don't know how long this live stream's going to go on for, but we'll go through the theorems. So, linear dependence of a linear combination. You have a linear space X, you have a collection of vectors in X, we have another collection of vectors W in the span, we have M of them instead of N, and we want to show that if M is larger than N, then that collection of W vectors forms a linearly dependent set. So you proceed by induction. For n equal 1, everything's pretty easy to do. There's nothing really tricky about the base case. And then you do the inductive step, so you have this family of W's, which is given here, written out explicitly because it's in the span of the V's. Where do you study? If you look at I don't like saying out loud, but there's enough information on the channel that you can figure it out. Are you into solving integrals like Math 505? I don't really do much integration anymore. Most of the stuff that I do is proof-based math, specifically in measure theory and harmonic analysis. Book of proof can be used for discrete math, to be honest, but if you like the specific topics of the book, then you should go deeper. Okay. How far along are you in your research? Not far enough, unfortunately. It's kind of annoying. I've expected to be farther along, but it is what it is. I'm not going to complain. So if AKN is equal to 0 for every k, so that means the final column of vectors, then as m bigger than n minus 1, you can use the inductive step to show that the family of W's is linearly dependent. So now you can assume that there exists an index k0 where ak0n is not equal to 0. So then you have wk prime is equal to wk minus, okay, so we have this new definition, or not new definition, but this new vector wk prime for k between 1 and n minus 1. Notice that wk prime is in the span of vk. Okay, this makes sense if you just plug it in. So we know what wk looks like because it's expressed here. So you plug that in, and then when you plug in wm in the last line, you'll see that the algebra isn't there, but the last vn will cancel with it. Will cancel. So it'll be an element of the span of vk from 1 to n minus 1. Riemann sums versus integrals. Which do you like dealing with more? Probably integrals. Actually, I prefer Lebesgue integral. Hi, grad student. I wanted to post the response to the existence of constant Cn, but the vid is taken down. I hid the video. I might make it public, but I kind of explained earlier why I made it private. I didn't want to upset anyone because my Quran wasn't at the top of the pile of the books. But if we have m bigger than n and m minus 1 bigger than n minus 1, then there exists a family of coefficients not all 0, where we have 0 is equal to this, which is good because it's linearly dependent. But we can substitute in what we know about W1 prime, which is given here, which means that this family should be a linearly dependent set. Do you guys think failure will lead you to being a bad professional? It depends on how you deal with the failure. So if you let it, win, if you let the failure win and not keep going forward, then my opinion would be yes. But if you know how to deal with the failure, then failure only helps you because every single person fails, including those professionals. There's no one out there that does everything perfectly. At least I haven't met this person. All right, hopefully, Theorem 1's not bad, but I really don't like theorem 1. I like theorem 2. Theorem 2 is where it's at. How old are you and how many years does a PhD take? How old am I? I don't know. Let's say, this isn't my age, but it's close enough. Let's say 30. How many years does a PhD take? Apparently it can take upwards of like 7 years, which I'm not a fan of. Rank nullity theorem. Yes, we believe in rank nullity supremacy, as illustrated on my board. Rank nullity theorem. X and Y are finite dimensional vector spaces. T is a linear map from X to Y. Then the dimension of X is equal to the dimension of the null space plus the dimension of the range of T. So, because I have to explain everything in full detail, I'm going to prove that the null space and the range are subspaces. It's not too hard to see. But the crux of the proof involves extending the basis of the null space to a basis of all of X. So I've written that down there at the bottom. And then you make the claim that the set of all TVIs from 1 to M based on my index is a basis of the range. In which case, you'll get the dimension of X is N plus M, which is that. Okay, so you just have to show that it's a linearly independent spanning set, which, you know, it's not too bad. This theorem is very straightforward. There's nothing crazy here. If you know your linear algebra, this is not going to be a hard theorem to prove. I'm not worried about it. Hopefully, everything will be good. And I'll get theorem 2. Why do they have linear algebra in a PhD program? This class is different. This class is supposed to be like a refresher course that's supposed to help graduate students that are weak in some areas prepare for graduate level analysis, which, to be honest, I don't think I needed to take this course at all. I mean, I've already taken linear algebra 3 times. I feel like this course is just designed to make me fail or tank my GPA, whichever you prefer. All right, let's hold off on theorem 3. Let's do theorem 4. You're thinking of going into graduate school. To be honest, I'm just bored with my job. It's a lot of work. I don't want to discourage you from going, but you should put in a lot of thought before going into a graduate program. I kind of knew for a really long time that that's what I wanted to do. And so when I made the decision to come here, I knew I was going to put in the work, because it's been a lot of effort to make it as far as I did. I made it way farther than I should have. Most of my friends never really from high school never made it this far. Do I make money off my channel? I can have it monetized, but I choose not to. I don't know why. I have my reasons. The reason I skipped for theorem 4 is because it's the classic Cauchy-Schwarz inequality. It's everyone's favorite inequality. X is a Euclidean vector space over the complex numbers. X and Y are vectors. Prove the following inequality. So I denote norm of X as absolute, square root of the scalar product of X with itself. How hard would it be to name a theorem something goofy, assuming you even get it published? You know, there's a lot of goofy named theorems, like the ham sandwich theorem. That's an actual theorem I learned about. Hey, when I start reading a math book, it seems like a big mountain to cover. I feel like it takes ages to complete one chapter, which I do. You might be reading something that's a little bit above your level. Try finding another, the Harry Ball theorem, classic. Try finding another book that's in like that field that explains it. You know, take baby steps, because it took me a really long time to get used to the language that mathematicians speak. And eventually you make it there. You just gotta really work for it. Was there Hahn-Banach theorem? There was. I'm gonna get to it next, but I skipped to Cauchy-Schwarz because of how easy it is. The one that I'm doing here is not the one we did in class. It's the, what is it? It's the one that involves the Pythagorean theorem. So the claim is that we have equality if X and Y form a linearly dependent set. So I do the reverse. Actually, I did this on the channel not too long ago. I don't really need to do this. When I had Stanley Kubrick drawn up on my thing up there. But anyway, there it is again in all its glory. I proved the Pythagorean theorem, just in case he says you can't use Pythagorean theorem. You need to prove the Pythagorean theorem if you want to use it. But anyway, I've done this so many times, I'm just wasting my time looking at this. What's the hardest undergrad math class I took? I would say math proofs. When I took proof-based math the first time. Because everything before that, without the proofs, was easy for me. I didn't have to do much. So I thought, oh, I'll be a mathematician. It'll be easy. False sense of security. Famous last words. Quite evil, if you ask me. The Hahn-Banach theorem. So X is a finite dimensional vector space. E is a subspace. You have a functional V0 prime and E prime. So that E prime is the space of functionals. Can you say a rough sketch of the Heine-Borel theorem? I do cover it in the measure theory review series, which is slowly but surely getting done. P is a semi-norm on E, and we have the property that the absolute value of V0 prime is bounded above by P for all V and E. And we want to show that there exists a functional V prime that gives us the following two properties. Okay, so the entire first page I can do in my sleep because it makes a lot of sense. You proceed by the induction on the dimension of my space E. Proof-based math was mind-blowing. It took me a while to fully get a hang of it. Yeah, I ended up having to take that. I say I took it 4 times because I kind of did. But after that, I was really comfortable with proof writing after that. It just takes a lot of effort. So what can we say? We write EK plus 1 like this. It's good enough just to consider t equal to 1 because you can factor out t, provided t is 0. But if t is 0, everything's great because then you'll just, what do you get? It just reduces to the original assumption that you've assumed to be true. But you can pull out the t like I did in the top row, and you can cancel it if t is not 0. All right, so the next line comes from just ignoring the absolute value, and then you just add over, or excuse me, you subtract over the V0 to the other side. So this is the inequality that you get that I've underlined with star. Can you do the Fresnel integral? No, I cannot. First time you're watching live stream? This is actually the very first live stream. I've always wanted to do this, but it is what it is. I wanted to try it, see if I liked it. If I don't like it, I won't do it anymore. And then if you remove the absolute value and replace it with negative, then you'll get the double star inequality that I've highlighted. So now you have an upper bound on V prime EK plus 1 and a lower bound on V prime EK plus 1. And if you combine those two inequalities, this stupid weird angle, you'll get this, where my thumb is at. And then if you do some algebra and appropriately label your vectors E bar and E double bar, this is the step that really confuses me. I need to go through this over and over again. I read it in my Kolmogorov book. The argument in the Kolmogorov book makes more sense than what we've written here, although that's pretty much just the same. But I think everything here should be okay. And all it really says is that you have enough room in order to define V prime EK plus 1. And then you can appropriately extend V prime 0 to the next, yeah, you can extend V prime 0 to EK plus 1. And then you just proceed by induction on the dimension of those spaces until eventually you can get to all of X. Enjoying the stream? I'm glad you're liking the stream. I'm doing my own math work as I listen to you. Oh, that's good. I wonder what kind of math do you do, Eternal Burns? If you had to learn group theory again, what book would you use? To be honest, this abstract algebra book here, it does group theory weird in that it does it at the very end. But I think that book's very well written. It's very user-friendly. So I would recommend, I don't think I would go back over and do it again. I would use the same book, to be honest with you. It's a good book for learning group theory. I like the book a lot. Algebra I never really struggled with too much. I mean, I struggled with it because I struggle with everything, but... Oh, I forgot there's a complex place. What is your least favorite theorem? Any theorem that's like super duper long that I'm forced to memorize. There's a lot of them. Like the completion theorem is long. Constructing the Lebesgue integral for all types of measurable functions is long. Fubini's theorem is long. Any of those really stupid long theorems, I like theorems that are really short and sweet and it's easy to follow, like Borel-Cantelli. I like that one. What don't you like about pure math, if anything? Well, recently, I feel like pure math is just so... Sometimes it's so philosophical and it kind of overcomplicates things. I do kind of miss word problems from applied math where it's like calculate the trajectory of a rocket ship if it's traveling at this speed, at this initial acceleration, that type of stuff. The philosophical stuff of pure math can get a bit dry sometimes, and I know there were some I took number theory once. There was a subject in it like in the middle of the semester that even the professor himself said, "Oh, this is really boring." Even he was like, "No, this is bad. This is so boring. I'm sorry, guys." But when he talked about the Riemann zeta function, I was all ears about that because I've always wanted to know more about why that problem, the Riemann zeta hypothesis, is so hard to prove and so many people can't do it. I just wanted to know more about it. So from number theory, that's what I really appreciated the most. He also talked about the Goldbach conjecture, which I wish I got to pay attention more in that class at the end, but I was preparing for my qualifier. Is it worth learning category theory? You're probably asking, wait a minute, category theory. My friend Brandon Martin, if you're familiar with that interview on the channel, he would say yes because that's what he studies. But for me, no, because I'm doing only analysis. In fact, I don't really even know what a category theory is. You're doing derivatives, integrals of functions, basically Calc 3. I need to review my Calc 3. Do I believe in the axiom of choice? Sure, why not? Why not? I mean, other people believe in it, so why not? If V0 prime is real linear over E, then just repeat the argument of the real case. We consider the conjugate of V prime. So we can write V prime bar as follows, which is equal to that if you plug in I into the argument. So this is just plugging in I, and then you can factor I out because it's a functional, which is I V prime bar. I don't know why I write it this way, I just do. So if you restrict V prime conjugate to E, we should get the original V prime bar 0. And then you just plug and chug, baby. More triangle inequality at the end. So the only thing I gotta remember is really this top line here. If I can remember that, everything will be good. And it looks familiar too. I should just learn it, but I'm kind of run out of time, unfortunately. Why did I choose analysis over algebra? I was talking to my dad on the phone about that. And I think the only reason I chose it is because it felt like the thing I should do rather than the thing that maybe I want to do. Although, to be honest, I kind of wanted to do analysis. It was the thing that I felt like, it was my calling, so to speak. I know that's kind of a cliche, but... Whoa. Who is your target audience for your upcoming measure theory playlist? What topics should we be comfortable with? Really, I think it's for anyone that wants to learn measure theory or is taking measure theory and is absolutely lost. I think this is supposed to be a good review session for those people. That's really all I'm kind of hoping to get out of it. Did I have trouble with Calculus 1? If I'm being honest, no, not really. Calc 3 was a bit of a struggle just because of how tedious some of the proofs were. Or not proofs, but problems. Like it just took Took like a whole page just to do one problem. Although now, when I look back, I was like, okay, every single problem I do takes up a whole page, so it was a little bit different perspective. Love from India, love from USA. Is talent and creativity in mathematics important for success in grad school? I would say the most important thing that helps you succeed in grad school, at least like from my experience, is just being an insanely hard worker. That's really talent. Yeah, if you have talent and you're creative, that's great and everything, but mostly it's just all hard work. I mean, everyone kind of felt like that we're going into the program felt like, oh yeah, I'm really talented in math, but to be honest, it's just looking at what other people have done, knowing how to find stuff in textbooks, going to Stack Exchange, just being super aggressive with your studies. That's what makes a successful graduate student. Apex Penguin, hey, how are you? I'm doing good. I'll probably download the Elden Ring DLC in 2 days. I don't know when I'll get to play it, but I'm looking forward to the DLC. Theorem 7, eigenvalue, singular value, inequality. X is a Euclidean space. T is a linear map from X to X. You have eigenvalues of T, singular values of T. You count their multiplicity. You assume you have this ordering. And you want to prove that the sum of absolute value lambda j's is bounded above by sum of the singular values. My question, please. Hold on. What was your question? Can you please suggest me a textbook for IIT JAM 2024 exam mathematics? Unfortunately, all right, I need to call him back later. Okay, so how about this? I know it's only been about 40 minutes, but I do need to call that guy back. So let me go through this proof here, and then I'm going to call him. So we let VJs to be a basis of X, where T has the Jordan form with ones above the diagonal, and lambda J's are on the diagonal. Yeah, a struggling grad student. Struggling. He's always struggling. It's always a struggle here at the channel. Freaking everything I wanted to do, I wanted things to go smoothly when I entered this program. Little did I know that it would be nothing but struggles. Okay, so basically this is the picture that we get with our matrix. So this is the matrix form of T. So we know that TVJ is equal to the eigenvalue times VJ plus an element of the span of VI's up to J minus 1. Hello, Krishna. Please take a moment of time for seeing that exam on the internet. If I can, I will. But let's, I gotta prioritize my test first. Let EJs be the Gram-Schmidt orthogonalization of the VJs, which is good. So EJ is of the form alpha J VJ plus some element of the span. And we know that the span of VI's is equal to the span of EI's from 1 to J. What math topic do you think you've mastered? Oh, you never master a math topic. I struggle with high school algebra sometimes, even 5th grade math, which sucks. But, I mean, it is the way it is. I mean, there was, in class the other day, my linear algebra, the guy teaching the linear algebra course, he freaking, he was telling us about this unsolved problem in math, and he explained it, and he said, this is a great, I wish I could remember the exact statement, but it was about trying to find an upper bound for something about having to do with, it wasn't about linear algebra, it was about convergence of sequences, about having a sequence of vectors, and you sum them in such a way, then you get an upper bound for it. I know that's a really bad way of explaining it, but if I find the exact statement, I'll make a video on it in the near future. But the statement is unsolved, and they've been working on it for like a few decades, and he tried to make us feel better about, hey, I know that I know that a lot of you beat yourselves up for not being able to solve a homework problem. So just remember that this problem is still unsolved, even though it's a really simple statement. which I guess makes me feel better. But to be honest with you, I feel bad when I'm given a homework problem that I can't solve because it's a homework problem. If you give me a homework problem, I feel like I should be able to solve it. And if I work harder and harder and harder and I'm still not making progress on it, then it upsets me because it means that I'm not really where I need to be. You know what I mean? But if you give me an open problem and I'm not making any progress on it, then I don't really feel bad about it because it's an open problem. Everyone's stuck on it. So all that really tells me is that I'm normal if I'm getting stuck on a research problem that no one else can solve. I mean, yeah, some days you'll be really upset that you want to make progress and you're not doing anything. But it's more upsetting to me when I can't get a homework problem solved. Because it's a homework problem. It's supposed to be, you can do it. Who hates Rolle's theorems beside myself? I don't know. Rolle's theorem seems pretty good. How do you get unstuck in research? There's no real formula to get unstuck. You just kind of have to be patient. Talk to a lot of people. Maybe someone will see something that you don't see. Wait, so how would the process of grade this homework problem? No, you gotta prove everything exactly the way he wants it, or else you don't get credit. But anyway, after you pass the EJs through the map T, they're of the form alpha J, lambda J, VJ, where then you have some element in the span of EJ. I gotta be careful with these papers. There's crap written on the other side. And then the lambda J, EJ. Okay, yeah, that makes sense because alpha J, VJ is EJ. And then you get some element in the span of the EJs. So now we can express lambda J as the scalar product of TEJ with EJ itself. So then you take the summation of the absolute values of lambda J's. You do your substitution, and then he proved this inequality in class because I know he said that we had it, but this should be bounded above by mu J VJ scalar product. And that should give us the sum of the singular values. This problem, this shouldn't be bad. I think I should be able to do theorem 7. So how many theorems is that? That's 4 plus this one is 6. Or hold on, I can do math. I can do the first 4 theorems plus this one is 5, and I need to do the other theorems from my list. Like, I still need to do Cayley-Hamilton. But to be honest, I have no idea what theorem he's going to give. This is Cayley-Hamilton, but I'm not going to study this version. I'm going to study the one that he gave in class. Your norm is general or norm Euclidean? In that problem, it was the Euclidean norm. What proof exercise do you recommend to learn linear algebra, similar to proving how theorems for group theory? I would honestly, to be honest, I would just go through Sheldon Axler's book. He writes so well in that book. He proves things in a way that even like he's written the book in a way that a middle schooler can read, but it is pretty advanced mathematics. It makes you feel like you're learning math at the middle school level, but you can follow along. I wish if I had more time, I could just reread the book and appreciate it again. And I remember just going through each of the theorems proof by proof, writing everything up to make sure that everything made sense to me when I was going through advanced linear the first time. It's the reason why a lot of those proofs in linear algebra I can recall on the spot. Is organic chemistry easy or very hard? I remember organic chemistry being tough when I took it at undergrad. I remember it's mostly tough because of how demanding it is. Like, you gotta go into the lab and do crap and do experiments and write up reports, and then the exams are tough because you gotta memorize all that Latin. You're doing a pure math degree? Yeah, PhD in pure math. Your test is basically write down the theorem? No, you have to prove the theorem. What do I look like? I look like Henry Cavill, except the exact opposite of Henry Cavill. Oh my gosh, what am I doing with my life? It's been 45 minutes. Man, time really does fly. I sat down to eat lunch one day, and I just watched a YouTube video, ate my lunch, and then when I was done, I looked at the clock. Friggin' 1 hour had passed. I was like, there's no way it took me an hour to eat that little sandwich that I cooked. Anyway. Oh my gosh. So my plan for tomorrow, because my phone is about to die. So, when will you graduate so you can write me a letter of recommendation? I don't even know. It's going to be too long. Too long. Too freaking long before I get my PhD. I just want it so bad now. It's the only thing I want in life. What would you like to do after you finish your PhD? Honestly, I want to freaking, like, this sounds stupid, but I want to get married and have a family, to be honest. I just want to relax and do all that good stuff that everyone says is nice, but I can't think about that now. I can't get distracted. I've committed so much time to doing this. Thoughts on AI-assisted proofs? I think it's fine. Thank you for spending time with us losers. You guys aren't losers. Am I open to doing a postdoc outside the U.S.? It would be kind of difficult for me to do that because I come from a place in the U.S. that really doesn't leave. Like, I'm from like a small town, and nobody from that small town really leaves. So the fact that I left and was able to do this is kind of odd, and I didn't really even move that far away, to be honest. Okay, I'm at 3% battery. If you want to ask me something else in the last, one more question, and then I have to end the stream, unfortunately. How many hours do you study a day? Any jobs you are hiring? Good luck on your exam. Thank you very much. Who's my favorite mathematician? How big is your tool? My tool? What do you mean? What do you mean, my tool? What are you getting at here, James Romano? I know you. You ask weird questions in the comment section. What's wrong with you? Do you feel inferior when you're with someone better? Like an actual, like... I mean, sometimes I get insecure, to be honest. But, you know, I mean, you know stuff that they don't know, and they know stuff that you don't know. Love you, bro. Thanks. What does mathematics mean? Oh, now you're getting philosophical about philosophy. Appreciate the live stream. I think I'll do more of these in the future, but I don't know. Maybe. It depends. I don't like the camera, the way it's set up here. It looks strange, but it is what it is. What books good study? Oh, there's a lot of good books. Anything I have here is good. My favorite mathematician, by the way, is, what's his name? Cantor. Georg Cantor. Get out of my head, man. Keep up the great work. I bet you're a cutie. What is wrong with you, James? Was it hard to adjust to teaching your own classes? No, not really. I mean, in the beginning, yeah, it was because I was nervous, but you develop a lot of confidence and you're able to get up and speak, especially if you've taught the class. If you've taught the class a number of times, then you get pretty good at it. Study hard, chase your dreams. You got this, chat. Very good. Apex Penguin's weirder, apparently. I have a suspicion that Apex Penguin and James Romano know each other. Do you know Math Sorcerer? I know of him. I know his channel. I've watched his channel a lot. I think he knows who I am, which is kind of an honor because he's like one of the big math channels. I like him. Been here since 5K. Yeah, I'm surprised at just how, like, fast this channel has grown. Like, in the very beginning, it just was, like, apparently I tapped into a market that wasn't tapped into, I guess. But, you know, my channel has since flatlined a little bit since then. I need to, if I want to keep expanding my channel and do something great with it, then I need to do something new. But I never really got into the YouTube game to be a YouTuber. I just wanted to upload videos to YouTube, and if, you know, if they helped someone, then that was good enough. But I'm glad people are getting stuff out of it, to be honest. Have you done many physics courses? I have not. Can you work out Cohen's proof? I'm not sure. Well, I'm glad you guys like these videos. It's been about 50 minutes. Please keep making videos. Yeah, I've always been making videos. I've been making videos for a while. It's only recently that this channel really kind of popped off, and now it's almost, you know, up there at 50,000 subscribers, which is insane. So thank you for watching this stuff. I think, what is it? For my future big goals for the channel, I think I want to do, if I'm comfortable being in front of the camera, I think I will do like a complex analysis. And if I have the time, I'll do a complex analysis review, or not review, but like lectures. I think that would be fun. Doing something with functional analysis would also be fun. But the measure theory review series needs to be done first. That's the thing I'm doing right now. Take an undergrad complex variables or linear algebra 2. I would do both. Probably linear algebra. I would do linear algebra, then complex variables. Go through proof step by step. That's what I'll do in the measure theory review. I'm looking forward to it. Make an analysis course on YouTube. Studying mathematics is chaos. We'll see. Discord, I don't know. I'm a little bit paranoid when it comes to Discord, so I don't really want to do it. When am I posting it? I've done the first 4 chapters. I started chapter 5, but I was feeling kind of, I was gonna say depressed that day, so I didn't finish filming them, but I was really just sad. So I started filming. I was trying to get through it, but I was in my feels that day, so I stopped recording, and I haven't picked it up since then. But as of right now, the measure theory review is 40% done. And when it's completely done, that's when I'll start uploading those videos. Your channel is one of the more comfortable math channels, which I really like personally. I try to keep it, you know, I try to keep it light. Although I wish the production value was a little bit more. I'd probably get more attention. Axiom of choice with the spectral theorem. Have I checked out Tao's measure theory book? I have. It's a bit aggressive for me, to be honest, but maybe I'll go back and read over it. To be honest, I have my favorites. I really do. I like this book. I like the measure and integral book. I like this real analysis book that's underneath here. I like it. Do you have any other interest, for example, computer science or physics? If you do, how do you manage it? Yeah, I really like history. I was a big history buff. History was probably my second favorite subject in school. In fact, I remember I was telling my dad a story about, oh, I'm at 1% battery. Okay, yeah, I really gotta go. So I was telling my dad a story about something in history. He's like, how come you didn't get a degree in history? I was like, because math is better. I just like math. It is what it is. Okay, my phone is gonna die. I'm at 1% battery, so thank you all for joining me on my study session for my test tomorrow. Hopefully I won't fail. And if you're studying math or anything else out there, good luck. I'll see you in the next video.